Mr. Crispin96 here again with another workshop video. Today we're going to take a look at the cylinders, and as many of you will know, two sets of cylinders are required, one for each side of the locomotive. But before this tiny little drawing confuses you, I'll show you a basic sketch of the outline. And in my case, I'm going to machine this from solid in three pieces. That is a main block out of mild steel, and then two cast iron liners. One plain liner for the main bore that the piston runs in, and another more complicated liner to go at the top end, which the piston valve will run in. And I'm going to do a video in a week or so explaining exactly how a piston valve operated cylinder will work, but for today I'm going to just concentrate on the manufacture of the two valve liners. Then when a further explanation comes of the whole system, it'll be a bit easier to understand. Today's job is to turn one very plain liner, and I'm going to skip over this very quickly first, and then we'll get on to the more complicated and more interesting liner that sits in the top. I have a basic sketch of the liner that fits in the top, and it is a cylinder with two radial grooves, and in each radial groove there are 5 steam ports. These are slots that go right the way into the internal bore. Now, one bit of information that's quite crucial to the whole build is that neither the bore of this liner or the bigger liner are going to be finished machined at this stage. The actual bore through the middle is going to be left undersized, and it will be machined out accurately using a different technique once the liners are inserted in the steel block. So into the workshop, I'm going to spend about a minute going through these plain cylindrical liners for the bore, and then the majority of the video is going to be on machining and measuring these more complicated bits. That's a hole all the way through. I'll open that out with one more drill size, then I will switch to boring. Before I bore this out to the finished diameter and end up with a thin wall thickness, I'm going to turn the OD, and that's because the OD has to be pretty accurate and pretty parallel, so I don't want any flexing. So I'll turn the OD down and then just come and lightly skim this out to roughly 1.5 inches. Remembering, of course, it's not crucial at all, as this is going to be accurately line bored once the liner's installed in the cylinder block. I'm just taking a finishing cut now, or a semi-finishing cut. After this cut I'll run it again at the same settings to take a spring cut, and that should give me a nice and parallel diameter. So before I take the spring pass, this end is at about plus 1/2 thou, and this end is at plus 1.5. So that's the spring cut. And now I'm 1/2 thou undersize. And that side is dead on, so there's about 1/2 thou over that length. I may take another spring cut and see if that comes out, or I may move on. So I've now got the two liners for the main bore, and it's time to work on the valve liners, or the steam chest as it's officially known. I've done one already, and as you can see, it's basically just a rough bored cylinder with two grooves in. And seeing as I've just shown a lot of drilling, boring and turning, I'll do all that off camera, but I'll just show the grooving operations. I'm going to do all the turning and grooving with centre running in this end, but for all the drilling it's going to be hanging out like this. If I had a fixed steady, once I'd turned the OD I could hold this with a fixed steady while I do all the drilling, but I haven't got one, so I'm just going to have to accept this length of stick out. Right, I'm just setting up to cut the grooves here, and as you might be able to see I've scribed two sets of lines. Those are the positions of the grooves, and to cut them I'm first going to plunge in with this grooving tool more or less in the middle, and I'm going to cut a groove that's maybe 3 thou bigger than the finished diameter. Then I'll come out and step over and go back and take the groove to width, and then once I've got the groove to width and a bit big on diameter, I can feed down one side, feed along the bottom, and come back out to give me a nice clean groove. Then do the same here. I'm running very slowly indeed. This machine struggles with this kind of work sometimes. Taking a measurement, I'm about 0.07 of a mil big, which is about 3 thou. So I'll stop grooving in now and I'll move over to the side. In terms of measurement and order, this is going to be my datum face. I faced this off, and that is where all my dimensions are going to come from. And initially I'm going to get this overall length right, from the datum face to the nearest wall of the groove. Then I will be able to measure the width of the groove based on this wall, which should be right to the datum face. Then for the second groove down here, I'll measure the near wall again to the datum face. Then get the width of the groove right based on this side. So I'll be steadily working along, basing all the dimensions from this datum face. So I'm now opening the groove width out. Having opened that groove out a little, I'm aiming for 32.54 mil, which is 1 9/30 seconds, and I've got 32.94, so about 0.4 of a mil to come off. Hopefully you understand the method I'm following, which is the main bit of information here, so I'll do the rest of the actual grooving off camera. So having got to the same stage as both of these now, I need to face down the parted off end to bring it to a nice overall length, and then I've got to turn 4 recesses, one in each end of both bit, and these recesses are 15/16 deep and 29/30 seconds in diameter. To help me, what I've done is I've taken a piece of aluminium round bar, I've drilled and tapped some holes in it all the way around, and then I put it in the lathe and bored it out to a nice fit with the piston valve liners, and this will allow me to quickly and accurately change the bit or the end I'm working on, so I can machine this end, flip it round, machine the other end, and as you might have noticed, when I load this in here it comes up to a nice stop on the back, so I can effectively set a stop up on my carriage, and when I come to bore the recesses I can just bore them all to the same depth. As I briefly mentioned, the gripping is done by these brass screws, which are in pairs across the diameter, and they should grip well enough. So before I start machining, it'll be interesting to see how much run out I've got here. This is my Mercer 10th clock, so each division is 1/10 of a thou, and 0 to 1 is 1 thou, and in the untightened position there's very little run out at all. Now when I tighten these screws up I think there'll be more, so we'll have a look. I've nipped all the screws up and it's not got any worse, which is a nice surprise, so now on to machining. I've measured the overall length and it's come out at 4523, and I'm aiming for 4.5 inches, so I'm going to touch on and then take a 20 thou cut and a 3 thou cut. Now part way through boring these recesses as described earlier, and seeing I've got 4 identical ones, I've taken a few measures to help repeatability. One being I've written down the number of what to bring the cross slide to, so that I should get the same diameter every time because I'm not changing the tool. And the other is in terms of length, I've set a stop up, or in this case a clock. I don't have a stop for the myford, but all I do is take this clock on this stand and put it in a position where I can feed the cross slide up to it and the needle will move accordingly. So I've zeroed this out for a depth of 15/16. A stop is probably a bit better and it's less likely to get bumped, but one nice thing about this is during all the roughing I can feed up to say 3 thou off 0, and then come to the final pass I can come to 0, and then right, I'll bore this one on camera and I'll turn that round so you can see what we're doing. Coming up to the needle now. And again. Right, there's about 9 thou to go on the dial, so I'll take 5 thou and then measure it. As far as measurement goes, I'm using one of these internal bore gauges, and by adjusting this screw on the end I can control the width of those 2 semi-spheres, and you just put this and I like these gauges quite a lot because they give you a good feel for parallelism and even surface finish, and then you just measure that width with an external micrometer. 8 thou to come off, so that's 4 thou on the dial. So now I'm going to wind the boring bar into the clear space in the middle until the clock reads 0. Then I'm going to lock the carriage and now feed inwards until my cross slide dial reaches the number I've been working to. So now to mill the radial ports. So as you've seen, I need to cut 5 slots around the circumference. So what I've done is I've taken this dividing head with fixture in it from the lathe and screwed it onto the dividing head, and having adjusted the jaws slightly to reduce the run out, and having clocked for parallelism to the bed and alignment with the x-axis, I'm now ready to start milling. So first up I'm going to use this Starrett edge finder to find the edge of the diameter and this front face. So we're ready to go, and I'll just talk you through all the steps as I do them. So first up, we're going to put a 10-hole PCD in with this centre drill. Now what I'm basically going to do is leave a gap between one pair of holes and remove the metal between the next. So I'll end up with 5 slots and 5 connecting bits. So I'm going to go around with a Sharpie and mark all the bits that I don't want to cut. 1, 'So now I'm ready to remove the metal in between these two holes, and I want to be able to plunge in with a milling cutter. So what I'm going to do is drill the 2 centre holes out with this small drill, but I'm also going to put another hole in the middle of each pair of holes. So that's now 5 sets of 3 holes, and I'm going to use a little milling cutter and open those out into slots. The milling cutter of choice is this little 4.5mm solid carbide end mill. So what I'm going to do is to bring the piece round to about this position, plunge in through the middle hole to full depth, then rotate the dividing head until this edge of the cutter comes to the extreme edge of this hole, then rotate back until the back edge of the cutter comes to this extreme edge, and that should leave me about 0.1 or 1/4 hour side just to clean up. Then I can step back in X and clean up the back face, then step forward in X and clean up the front face, again just milling in until the cutter reaches the extremes of the slot. We're through down to the bottom. Back to the other extreme. Now I'm going to feed over in X and just come back a little at a time until I blend with the edge of the groove. I'm blending with the edge now, so back to the front and then back to the back. Now feed over in X and clean the front of the groove up. blending with the side now, so right to the front. And right to the back. Now step carefully off the face and feed out. And there we have one radial slot. Now to do all the others. Having cut all 20 slots, I now want to scallop these edges. By scallop I mean kind of cut the corner away like this. And that will serve two purposes. One, it gets rid of the sharp burr, and two, it allows the steam to flow a bit more freely inside. So I'll show you how I'm doing it. I'm using this little 4.5mm carbide cutter still. So to do it, I've got the part rotated round till this corner is presenting itself evenly to the tool, and then I'm winding into a depth, coming back, stepping across, going in, stepping back over and going in again. Touch onto the side and back off slightly. Now touch onto this side and back off slightly again. And that's a scallop cut, as you can see. Now to do that another 39 times. The valves are more or less finished now, and I thought I'd just show you how I'm measuring them. The datum symbol you saw there is so I know which end I'm measuring from. And to accurately measure these is quite a challenge, because the only thing that I can really get in there with is a digital caliper. But to get a bit more accurate, I've got my 10th clock here, and I'm using the bed of the lathe because it's the flattest surface I've got. And then I've got a stack of slip gauges for the size I'm after. I can zero that out, and then holding the datum end down, I can measure the position of these faces and go around checking how close they all are to zero. Now that was measuring downwards, but if I want to measure upwards I have to set up slightly differently. So for measuring upwards, first of all I've set the clock needle pointing upwards, and like most clocks I can measure in either direction with this. Then I get my slip gauge stack and then a piece of ground something or other, and that can slide on top. And the benefit of doing it this way rather than turning it upside down and measuring on top is that I'm taking all the measurements on the same face. So I actually have a true reading of the distance between those faces, which is what affects the timing. So I can now move in there. So there's the work from this video, and we're about ready for the main cylinder blocks. Between now and then you can look out for the video explaining how a piston valve cylinder works, and otherwise I hope you've enjoyed watching, and see you on the next video.